He leads many of the important software projects on the infrastructure side, on the inference side at Daydream. And I think he's somebody who has really gone through the fire of trying to run these real-time models at scale and running them on GPUs that are constantly broken. So he's going to be sharing some hard-earned lessons that comes from a lot of pain along the way. So welcome to the stage, Victor.
Hello. Cool. So I'm going to do a quick high-level overview on the architecture for the Daydream API. And just as a quick introduction about myself, I'm Brazilian, and I work on the Daydream team, on the AI infra team. And I do a lot of the inference runtime and like routing and video streaming protocol that we built for this. And what is the Daydream API? The Daydream API abstracts an interface for running real-time video AI without having a local GPU, meaning that you can just use an API and connect to a network of GPUs, and you can run your inference out there and get the result on any device. So you don't need like a powerful workstation with a big GPU to be able to run these models. And we also do this streaming in a real-time fashion as well, so you can get sub-second latency on everything that you run. And you can build the interactive experiences that we are looking for. And so just to give some example of what we can run on this service. So Stream Diffusion V1 is our flagship pipeline right now, and that's what we've been talking a lot about today. And yeah, I don't need to explain too much what that is, but just other examples of things that we have integrated with before. We've done ConfStream, which is a way to run ConfUI pipelines, workflows on a streaming video. And we've also integrated with faster live portrait before, which allows like face swapping, more optimized and then faster. And soon, we're also going to be integrating with Scope, which is the research tool for running these pipelines easily. And this will bring easily Stream Diffusion V2, which was recently released, and also long live support on the API. But the idea is that any pipeline that is integrated in Scope could be easily made to run on the cloud infrastructure simply by us upgrading the Scope version. So it's going to be a really streamlined workflow from the Scope research phase to actually running these models in our infrastructure. And finally, we are also working on the BYOC, which like bring your own container, making it really easy for anyone to provide a custom pipeline and run it in our service. And all these pipelines have a common and simplified interface. Like you just, in the end, they're just getting images and outputting images. So that's the simplified interface that we have to provide. And just to dive a little deeper on the architecture itself, we can look at a few of the challenges of running this real-time AI at scale. And first of all, we have a very tight latency budget, because we want things to be interactive. We want to return the output to the user as soon as possible, and for the experience to be, well, real-time, right? So everything has to be, like, we can't have many buffers on our system. The inference has to be really, really fast. And Ryan just talked about many of the optimizations we did on Stream Diffusion as well. So it runs SDXL, runs other features, all in real time. The throughput and bandwidth is also a challenge, because we're not only using a lot of GPU power, but we are also streaming these videos, this multimedia across the internet. So it's a lot of GPU and it's a lot of network as well. We can't have just beefy GPUs. We need like a flexible, powerful networking architecture as well. And there's also the hardware variability. So every machine that runs these models could have a different CPU, a different GPU, different memory architecture, and all these things affect the final performance that we can see, let's say the FPS of the stream. And so we have to account for that on the engineering side, and we need to make sure that the user can get a consistent experience, a predictable experience, even though the hardware underneath or the network might be not so homogeneous. Another challenge is that these models are pretty heavy, so it could take several seconds, like even a minute, to load a full pipeline on one of the machines. So we need to have some smart routing and smart caching so that users can get a really quick experience. Once they start using the API, they start streaming and they get a response right away. They won't wait for a whole model to load. And finally, the stability, because we have to do all that while still keeping like a good experience for the user, not many errors, like if having fallbacks, if there's any problems with any machine, switch quickly to another one. And yeah. So let's see the architecture itself. This is a quick overview of some of the components that we have. And yeah, let's dive deep on each of them. But here you can see pretty much the application layer. So the user, the developer using the API would come from here. And this goes lower level in our stack, in our architecture. And so looking at on the left side first, we have the app, which could be like a web app. It could be a mobile app. It could be the Stream Diffusion plugin that we just saw as well from .simulate, Stream Diffusion TD. And the app calls the Daydream API. And I like to think of the Daydream API as the control plane. So it defines what are the streams, what are the parameters to use for each pipeline. And it handles the authentication with the user. It handles the parameters of the pipeline. And it returns to the app the endpoints that it should stream to once it creates a stream with certain pipelines. And then the user streams gets the endpoints from the Daydream API, and they stream their video to the gateway. The gateway is the one that actually handles the media, so it's kind of like the data plane or the entry point for the media. And it connects to the app with WebRTC, which is a reliable protocol to communicate over the internet from potentially not as fast connections, like on the user side, maybe a mobile phone, a crowded Wi-Fi network. And the gateway then handles this stream and terminates the WebRTC there. So now we have just a video stream. And we are also a video streaming company, so we could leverage a lot of this knowledge we already had as well. And this gateway is going to talk to internal orchestrators. And we have several orchestrators. They could be seen as, understood as like the entry point for a data center. So the gateway knows which orchestrators are out there and which ones are busy, which ones have available capacity, and what are the capabilities of each. And then it streams that WebRTC stream, that media. It streams to the orchestrator, but it uses a different protocol. Instead of WebRTC, we created this HTTP trickle, which is basically a stream protocol based on HTTP, so it's simpler. We basically push and pull segments, and the orchestrator serves as the main piece there. And so it gets the segments from the gateway, and then the runner on the other side, I'm going to explain later, pulls these segments and then pushes the output back, etc. And the orchestrator also manages the runners, which actually do the inference, the real-time inference, inside the GPU clouds, which is this final piece here, which is basically the inference layer. So the runner gets the input video segments by segment, and then it decodes this video into frames which is what the AI models actually work on, they actually understand. And it runs the inference from these frames, and then encodes the output back into video segments, which are streamed back through the orchestrator. This runner also makes sure to keep the pipeline loaded in memory, as I mentioned, like warmed up. So when a new stream starts, it's already there, and it can already do inference instead of like loading the pipeline from nothing. And it also has like an extensible base class, so that it's really easy to create new pipelines. And yeah, that's it. The Daydream API abstracts all this real-time video complexity, and you get a simple API and stream via WebRTC, and you can already get the stream diffused output on any application that you want to build. And these pieces that I explained, keep it modular and keep it predictable solve all those challenges that I explained. And yeah, we have a same architecture that could run on different hardware and with different pipelines. That's it. Thank you.